Let's say you have a pocket full of change and you want a quick estimate of how much money's in your pocket. You reach in, pull out some quarters, some nickels and dimes. After a quick scan, you guess that you have about $5. A friend calls you and asks if you'd like to go to the movies. Well, the tickets cost $5. Do you have enough money to go? At this point, you don't have enough information. You know that you have more than $4, but not as much as $6. Unfortunately, the cashier at the movie theater will not accept about $5 as payment. She is going to need $5. Science often requires precise measurements. After all, NASA is not going to spend billions of dollars on a mission to Mars armed only with the knowledge that the red planet is approximately 250 kilometers away. And let's hope that if you ever need emergency surgery to have your appendix removed, the last thing you hear your doctor say before the anesthesia knocks you out isn't, "So the appendix, that's somewhere on the right side of the body, isn't it?" So let's take a look at the rules. They're really straightforward, easy to use once you get started. Rule number 1 says find the first non-zero number starting from the left. So just like when we were doing scientific notation, you look from the left and find the number. In this case, we're looking for things that are not zeros. So example with A, the 2 would be the first non-zero number, and B, we have a bunch of zeros, so it wouldn't be until we got to the 1 that would start counting. Okay. Rule number 2, if there is a decimal in the number, everything after the first non-zero number is significant. 3, if there is not a decimal, zeros at the end of the number are not significant. And number 4 deals with a special case, counting numbers, exact numbers, things that are constants. These are determined to have an infinite number of significant figures, okay? Infinite number of significant figures. So something like 6 molecules. Well, if I have a molecule of H2O, okay, if I have water, I've got the whole thing or I've got nothing. I can't have a half of a water molecule. There's no such thing as that. And similarly, 60 seconds is exactly 1 minute. There is exactly 60 seconds in a minute, and 1 minute equals exactly 60 seconds. So these are not measurements, these are constants. Okay, so let's go ahead and use these rules to count the significant figures in these examples. Okay, remember we're always looking from the left, trying to find that first non-zero number. So A shows 25.2. Well, that first number we get to is not a zero, so we're going to start counting significant figures from there. And then we're just trying to determine if there's a decimal. Yes, there is. That means that anything after this first significant figure will be significant. So 1, 2, 3. Okay. B, we're looking for that first non-zero number from the left. There it is. And there was a decimal in the number. That means that everything after that first significant figure will be significant also. So 1, 2, 3. C. Okay, the first number is non-zero, so we'll start counting from there. We said that there is a decimal in the number. That means that everything after this first one is significant. So there's 1, 2, 3, 4 different numbers there. They're all significant. Next one, 1500. Well, the first number is non-zero, so we'll start counting from there. We see in this case that there is not a decimal in this number, so that means that zeros at the end of the number are not significant. You see how these 2 zeros are just hanging out at the end of the number? Well, that means that they are not significant, so only the 1 and the 5 in this case are significant. For E, we start counting once we get to the first non-zero number. There is indeed a decimal in this number, so 1, 2, 3, 4 numbers are significant. Okay, 25 students. Okay, well that's one of those counting numbers there. Alright, you can't have a half of a student. I suppose you could, but that would be a messy situation, and it does not count as a significant number. There's an infinite number of significant figures here, so the correct answer for this one It's infinite. And finally, G, 6.02 times 10 to the 23rd, Avogadro's number. We see that the first number is non-zero, so we'll start counting from there. There is indeed a decimal in this number, so all the numbers are significant. So this is 3 significant figures.